number, this is heading from chapter 7, similar figures. What is a similar figure?
They're like the same shape but different size. Yeah.
That was so good.
I just guessed from the picture.
Was that a good hint though? All those polygons up there?
It wasn't really hint, it was like
Yeah, it was, you're right. Remember, similar figures, this is just a review. They're the same shape but different sides. Your angles are all congruent, I should say. And your corresponding sides are proportional. So remember, that means they reduce to the same scale factor. So what would our scale factor be here if you had to match up two sides and find its scale factor? Oh yeah, times 2. Or if you went the other way, it would be 1/2. Right? Good work. Yep, so remember your scale factors, if I pick 2/4, then reduce 1/2. Perfect. Good work. Okay, so we have this little first thing here. Pop your notes. So it says, let's find our scale factor. Let's put figure B over A. So, who wants to get a scale factor? 5K over 5? Can we reduce that?
Yeah.
Right, 5's cancel, don't they?
Yeah.
So we get, okay. What would our perimeter be for figure B? How do you get 28?
5 plus 9 are 14. Just multiply it by 2.
Yep. This is 14 multiplied by 2, and we get 28K. What about for figure A? What'd you say, Reggie?
28.
28. Then remember, since this is a ratio, we always want to reduce. So what does it reduce to?
Okay.
A. And lastly, the area of figure B. Base times height, what do we get? 45K squared. Look at that, I can't seem to write a 5 today. And then for figure A, 45. What does that reduce to? Perfect. So let's look for a second here. What do you notice about your scale factor and the ratio of your perimeters? But they're the same, right?
Yeah.
These are the same.
You know, back in the answer for
It is.
nice. I'm doing those work.
It wasn't a lot of work.
It's so work.
What do you notice about your scale factor and the ratio of the areas?
It's the same thing squared.
It's the same thing squared. Perfect. So that is really what we're doing today. If we fill in this blank, two polygons are similar with a scale factor of some number over some number, A over B, then the ratio of their areas is A squared over B squared. Kind of a nice way to end the chapter. Very easy. So let's try problem. It says for each pair of similar figures, find the missing area. Okay, so this is what we're going to do. Start with your scale factor. Unless it specifies, I always keep a smaller number on top because I know that just makes more sense in my brain. So I write 5 over 8. And you always want to see, can you reduce? Can I reduce? No. Okay. Then from here, I want to write the ratio of our area. So I'm just going to abbreviate ROA, the ratio of your areas. So what did we have to do to our scale factor to get to the ratio of our areas? So here's your scale factor, A over B. Ratio of your areas is A squared over B squared. Square them. So what's 5 squared?
25.
8 squared.
64.
Perfect. And then from here, you're going to write a proportion and solve. So I'm going to write 25 over 64 equals, do we know the area of the small rectangle?
No.
Negative, right? X over 32. Now we just cross multiply. Someone's going to have to help me out and remember that is 25. over 30.
800.
Say 12.5. Centimeters squared. Okay, try to triangle one exact same problem. I'll leave this up so you can see kind of how to do it, but same process, just 10 different numbers. Start with scale factor. Reduce if you can.
What's that? That's what it says in the message.
Did I do it right? Did you do it right?
Yep.
Are we, is anyone agreeing
I
with me?
did it right, but I didn't do it that way. Because I didn't reduce anything.
But you still got the same answer, right?
Yeah, that's enough.
I only reduce because it gives you smaller numbers. But you don't have to reduce. Are we okay with that? Okay, so now the next set of problems, they're going to give you your areas, and you have to work backwards to either get your scale factor or missing side. So essentially, we're just going to kind of reverse this process a little bit. So let's see what we're given. So for the pair of similar figures, use the given areas to find the scale factor. So this time, we're going to go from our ratio of our areas to our scale factor. So what is the ratio of our areas? 50 over 72. And this one you always want to reduce, because they're going to hopefully always end up with like a perfect square for the most part. So what goes into 50 and 72? 2, right? So now I'm going to get
25 and 36.
right. So now think. Right now we are at a squared over b squared, squared, and I want to get to a over b. So how am I going to undo the squared?
Square root of square.
Yeah, take the square root. And that will give us our scale factor. So square root of 25,
5.
5. Square root of 36,
6.
beautiful. Okay, so we found our scale factor. And now we have to find x. So we can set up a proportion. This one's kind of weird, because what does it end up being? 5, but I'll show you why it works. So here's my scale factor. We don't know the small one, so I'm going to call it x. And then we know its matching side is 6. So now I'm going to get 6x equals 30, divide out x equals 5. You guys try the diamond, same idea, just different numbers. Same process. You guys at 16?
Yeah. Yeah.
Sweet. And if you didn't reduce, you would have been okay on this one too. 64 and 400 are both squares. You should still got the same answer, I think. Okay, then we end with a little application, a scale model situation. So it says the area of one side of a skyscraper is 90,000 square feet. The area of the corresponding side of a scale model is 200 square inches. If the skyscraper is 720 feet tall, about how tall is the model? So is that like the first set of examples you did or the second set of examples?
Second, yeah.
It's the second, because we know the areas, right? So it's just like the second set. So we're going to start with the ratio of our areas, and we got to figure out our scale factor eventually. You don't have to when you're working with scale models, because in the end, when you do your proportion, they cancel out. So you don't need to convert your units on this one, guys. So I'm going to put my model over my actual building, okay? So 200 over 90,000. We can reduce that, right? 200 goes into 90,000 how many times? Right? 450. Now what do we have to do to get our scale factor? Square root. And it's okay if we get a decimal because it's application. It'll just be an approximation. So 1 over, let's go to 1 decimal place. 21.2, so like that. And then from here we write a proportion. So 1 over 21.2 equals, what do we know? The skyscraper is 720. So x over 720 or 720 over x?
X over 720.
Beautiful. So 720 equals 21.2x.
34.
34 inches. Working. Nice job.